Hey there, want to start out with a data science project? Let's go for car or bike price prediction. Okay, because this project has been one of the most famous and most used for and very friendly for beginners. So let me take you.
This is Kaggle where I'm using Kaggle for showing, and as a beginner or to feel more comfortable, you can also do download this and use it in Jupyter Notebook. But then I'll be explaining these things in Kaggle so that it will be useful for you all. So here you can see this car-based prediction. Okay. So here I've added deployment because at the last we deploy. So we deploy the model, and you can also find this dataset in my GitHub repository, or it will be in the descriptions. I start off usually with import warnings because I don't like silly warnings. So therefore I usually import warnings. This is not necessary for you. It's actually not necessary for you. And here we are using import pandas as one of the most important data set in data science. Pandas is used for data visualization and also for many other things, mostly for data analysis and manipulation of the data. DF, PD, PD is pandas. As you can see here, we have imported pandas as PD. So PD is used here as short form to read the CSV file. This is how data sets are read. Okay, you can see different people reading different data sets using read CSV. You can just figure out how to add data sets in your Windows or Mac. It differs. Okay, the slash and the R comes here, so all those things differs. And then df dot. So very important thing to remember is we input this data to df. Okay, here we have used df several times. df.info gives us the information necessary about the dataset. So here we can see that this dataset contains 301 entities, that is 301 rows and 9 columns in total. So here the columns names are being displayed. So what are these all? All these things are the characteristics of a car. Dataset.describe. Dataset.describe gives us in detail description of this data. Here we have year, selling price, kilometers, and owner. And then count values 301 rows. Everything is 301 rows. And mean value, mean is nothing but average. In data science, it's used last mean. Standard deviation. This gives us a detail of how spread out the data is from each other. Minimum values and maximum values. ds.shape. As you can see, we have already got the information necessary in information. df.shape also gives us the same information, number of rows and number of columns. df.head gives us this one. You can put the values here like 5 or 10 or anything you require, and it gives out that many rows. So usually head gives out normally 5. Here to display the unique values. The unique tells us how many types of values are there in this. For example, seller type has only 2 types as dealer and individual. Fuel type has 3 types, petrol, diesel, CNG. Transmission 2 types, owner 3, which is 0, which is very new, or the first person who's just bought the car, first hand or third hand. I think this is like first hand, second hand, and third hand. So here we have used car names. This actually car name is a column name. but it contains all mixture of cars and bikes. You can see here KTM is a bike and Wagoner is a car, Swift is a car, and all those things. So it has many different vehicles. So is null is very important. If we have is null data set, if we have any null data set, it is very important for us to remove this data set or replace the null data set. So here we have zero missing values. Okay, is null checks for missing values. So luckily in the data set usually it will not be, but in this data set because it's a beginner data set there is null values. TF describe again. You have already done this. df dot columns gives us all the column names. So here we have 9 columns. So final data set, we are eliminating one column, which is car name. Okay, 8. Okay, out of 9 we have eliminating car. We can also use drop, but here we have used this method so that it will be easy for you guys. Final dataset dot head gives us the top 5 columns of this final dataset, excluding car name. And the current year, this year is 2022, right? So let's give 2022. This creates a new column with 2022 as the entire row. You can see this. Okay, it makes another new column with 2022. Head gives us all the values. And this is very important. You can see here. This is very frequently used in all the top data science projects. But then this is basic, and you should know how this works. Here, final data set, we have number of years of the car, which is equal to. This is actually number of years. You're creating a new number of year column, which is equal to final data set, which is current year, which is 2022 minus the final data set of year, which is this one. Okay, 2022 minus this one gives us the number of years, which is here, the number of years. Okay, so you can see here 2022 minus 2014 is 8. So this is number of years 8, it's recorded 8. So for each row it does the same thing. So here now we have got the number of years. Year is not required now. So let's take out the year by using the drop. Okay, you can drop multiple items, but then for your better understanding, I have dropped only one. Final data set. Here this gives the final data set without the year, and we can observe that even current year is not required. So let's drop this one too. So now datasets got to get dummies. So for your machine learning to work, you cannot give non-numeric values, whereas for machine learning to work, you have to give only numeric values. Therefore, let's give only numeric values. Let's get dummy variables. It converts the non-numeric to numeric data. So here you can see petrol is 0 and diesel will be 1. If it has more than 2 variations, it just creates a new column and then it gives out each column yes or no. Okay. There are many types of ways to convert non-numeric to numeric. So here we have used dummy variable creation. So this is how our data is right now in the final. So now let's remove this data set. Current year 2022, let's remove it by using drop. Final data set drop, and this one CORR function. This function gives us the correlation between each and every columns related to the rows. You can see this. Here we can ignore this the diagonal column, because it contains the versus, and versus is same. You can see the correlation. Selling price, present price, we have 8 correlation. Kilometers driven and selling price, we have correlation. So you can see in the later we'll be plotting this graph. So Seaborn, import Seaborn as SNS. Seaborn is a very important library which is used for advanced visualization of data sets. So now we are using Seaborn as SNS, or you can use Seaborn directly. Here we are using Seaborn SNS.pair plot. There are many different types of plot. So here we are using pair plot so that the pair plot compares each and everything. It compares in pairs and gives us, for example, transmission manual and selling price. It compares both 0 and 1. Okay, see, transmission manual, if it's manual, the selling is good. If it's not manual, the selling is low. So you can just find so many correlations here. So you can see that selling price. So selling price is low for the number of years extended. Okay, and selling price is high for the new cars. So like that, you can just find every correlation here, and you can create your own logical story here. Okay, that's all data science is all about. So you have seen we have used Seaborn. Now it is not necessary actually, but then if you have already used it, it's not necessary. But if you have not used it, you should use it. So here we are importing the new library called matplotlib.pyplot. This is used for basic visualization of data sets. And then after this comes Seaborn, which is a little more advanced visualization. We are plotting a correlation. So this is the figure size. So usually it comes smaller, but then with this fig size, plot.fig size, or fig is equal to plot.fig size, you're gonna make your own size. Okay, here we are given 2020, so that it's 20 and 20. The size is 20 and 20. You can give whatever size you want. And here you can see that we are splitting the data. Okay, this is called slicing data columns. So here X, we are taking the first column. Here X, we are taking every value from the first column, and Y will be the zeroth column, which is zeroth column is the basically the first type, the first column. Okay, this is first call index, which is which starts from second actually, but then in Python, its column starts with the value of index number 0. So 0, 1, 2, 3. So here 0, which is first column, and which is 1, which is starts from the second column. So X owner of Unix, we have 3 type of owners. We have seen it, but we need to recheck it. X dot head. So we have excluded the first column, which is selling price. So selling price, we have stored it in Y, and then rest we have stored it in X. So here we can see that. Now let's start importing the machine learning models. So let's use extra-tree regressor. Extra-tree regressor is one of the decision making, and from the extra-tree algorithm, like the random forest algorithm, creates many decision trees, but the sampling for each tree is random without replacement. This creates a data set for each tree with unique samples, a specific number of features from the total set of features, also selected randomly for each tree. So this is the model. After running the data set through the model, we get this as the output. Now let's plot this thing. So here you can see that we have plotted this graph, which shows us the better visualization. So now we go to the next part, is training the machine learning model. So here we have used this for printing the visualization of model. Now let's get real, and let's get into the visualization of the model. Here, sklearn.model selection import test train split is used for splitting the dataset into two, which is testing the dataset and training the dataset. So for testing, we are using ytrain and ytest. For training, we are using xtrain and xtest. Okay, so it trains using x and tests using y, and then tests using y. From sklearn.ensemble as the methods used, we are importing random forest regressor. So random forest regressor is assigned to this one, and this one is used for prediction. For training, import numpy as np. So here we are using numpy as np. Numpy is used for array calculations, and then you can see that n estimators. This is the number of trees you want to build before taking the maximum voting or average of predictions. Higher number of trees gives you better performance, but makes a slow code slow, but it doesn't matter. You get the accurate values. So here we are using random search CV to get the best to search the best model. Here you are using the features as auto and square root, and then we are creating a random grid. Okay, actually random search is a technique where random combinations of hyperparameters are used to find the best solution for building the model. Actually, hyperparameters are something which is used to tune the models. Tuning the model is getting the model to make predictions more accurately without overfitting it or underfitting it. Here we are assigning random forest regressor to RF. So random forest is used, and then estimators are calculated, and then we are fitting the model here. So here we can see that we are selecting the best estimator, and then we are fitting the model into xtrain and ytrain. So this xtrain and ytrain trains the data. So it automatically sees the ref and node, and also square root is used. So we get random state 42 as the best state, and this is actually the best model we can do. CV5, and the data here shows the best model. Yeah. So this is what we are considering as our best model, and the score is minus 0.014185. Let's use for prediction. So this is how we predict. So this is KNN algorithm. We use KNN.predict xtest, and xtest is used for prediction of the testing model. And this is the disk plot. Disk plot gives us the distribution. You can see this density at 0 is very high, and it goes low. This is scatter plot. You can see that this is not actually from year till year there'll be a straight line. So if it goes exactly in the straight line, it's a right fit model. But if it goes exactly on the line, it is overfitting. Here it is not going exactly on the line, so this is actually right fit. And underfitting is something which goes here. You can see blue spots here, so it's underfitting. So this is the perfect model, you can tell. We are using matrices. Matrices is usually used for checking the accuracy of the model. MAE is the mean absolute error, refers to the magnitude difference between the prediction of an observation and the true value. So it just compares the observation and the prediction and gives us the uh, final value. So here 89% it is true. 89% it is true. So it's right fit model. If it's one, remember guys, if it's one, it's a overfitting model, and if it's less than 70, it's a underfitting model. This is right. It's a good right fit, you can tell. And then MSE is the mean square error. It measures how close the regression line is to set a data point. It is a risk function corresponding to the expected values of a square root. Uh, and then RMSE is the root mean square error. Okay, root mean square deviation is one of the most commonly used measures for evaluating of the quality of the prediction. So it comes good, and then we use this model to deploy. Import.pickle. Pickle is one of the library files which is used to extract the model which is fit here. You can see that we have fit the model here, right? This model we are, yes, this model. So we have got the model, the best model. So this, yeah, 96. This model we are going to get into the pickle file. Pickle file is saved as .pkl, which is used for deployment or application deployment. Okay, this deployment will be the next thing, but till here this is the best thing. So now after exporting the pickle file, you can deploy this wherever you want. So here we are saving this file as random forest regression model pkl. So in the deployment we can use this name, this file, for our model building. Okay, so the model deployment thing I'll just be explaining to you in the next video. So hope you understand this, and please find this project in my GitHub repository. It is one of the easiest one, and also you can see this address. So you can go to Kaggle and you can start learning from Kaggle. It's a great project for learning, and please, when you contact me in the Kaggle, please try to make out the changes of your own in this thing by using many visualization libraries, and try improving this model and let me know, guys. If anything is there, please let me know. Thank you so much.